Hello and welcome to this video on quadratic graphs. So just to illustrate what I mean by a quadratic graph, we've got three examples just here. So these usually start with y equals x squared. So if we look at our first one that's in red here, you can see that it's just a bit of a shorter equation there, but you can see it's a nice U shape. So anything that's a positive x squared will always be a little U shape like this. Same with the second one as well, but obviously when we do our substitution there's a bit more to do on that one. And then the last one, when it's a minus x squared, it will take this sort of N shape just there. Okay, let's have a look at some questions then. So here is our first example then. So we've usually on the algebra graphs questions, you might remember from the linear graphs that quite often they give you a table of values to fill in first. Sometimes they don't, but what I'll always do is I'll draw one out if they don't do that for you. So what I'd like you to do now is just pause your video and have a go at this table of values. So let's take a look at our answers to this then. So first of all, we've got our 3 here. We're going to use that, substitute that 3 into the equation. So I would always break this down into 3 steps. So if we do our 3 squared first, we get 9. Then we're going to add on that 3 for your x in the middle there, which is going to give you 12. And then 12 take away 6 does give you 6, as you can see in the table there. Let's have a look at another positive number, then I'm going to show you some negatives. So 1 squared is 1. 1 add 1 gives you 2. And then 2 take away 6 gives you your minus 4 in the middle here. If we have a look at minus 1 then, so minus 1 squared is 1. And then we've got to do 1 add minus 1. So just remember on that first bit, whenever you square a negative it becomes a positive. On your second bit here, whenever you add a negative it becomes a subtraction. So that becomes 0, and then 0 take away 6 gives you minus 6. Let's do one more negative. So minus 3 squared is 9. Remember, negative times a negative gives you a positive. Then you've got to do 9 add minus 3, which is going to give you positive 6, because that's the same as doing 9 take away 3. And 6 take away 6 will give you 0 just there. So take extra care on those negative numbers. I would always make sure you do it in these 3 steps. If you do it with these 3 steps, you're less likely to make a mistake.
So the next step after calculating your values is to draw your graph. So you've got to plot your coordinates first. So we've got 3, 6 just there for your first one. Then we've got 2, 0 down here. 1, minus 4 here. 0, minus 6 just there. We've also got minus 1, minus 6 there. Then minus 2, minus 4, and then minus 3, 0. So you might notice on this one, it's not a nice straight line like you've got on the linear graphs. And it can be tempting just to use your ruler to do this, but you've got to draw this 3 hands. So you've got to go from here, just nice 3 hand, and it is quite tricky sometimes. There we go. And there we are. Now, as well as the drawing, they sometimes ask you additional questions like the one here. So it says use the graph to find estimates of the solutions to the equation x squared add x minus 6 equals minus 2. So you might notice that the y has been replaced by this minus 2. So what we need to do here is find the minus 2 on the y-axis. So it's just there, as you can see with my ruler. And you've got to draw a line through that. Like this, nice straight line. And you'll find, so that line is essentially y equals minus 2. So you'll find that the straight line hits our line here at 1.6. And then over here at, I think on mine, it's about 2.5 there. Okay. And you'll notice it's an estimate there. So it says the word, to find estimates. So estimates is a plural, means you're going to have more than one. And they're not necessarily looking for one exact value. So they'll base your mark for this question on your line here. So we can see on the one I've drawn, it's at 1.6 here for x and minus 2.5 there for this one.
So here is your next example then. Take care on this one, because if you look in the middle there, you've got minus 3x, so you've got an extra step involved, so take care when you do this. So here is your answer to this second one. Let's just pick out a few of the values here then to make sure you understand why these are the answers. So to start off with 4, we've got 4 squared, which is 16. Then we've got 3 times 4 in the middle, which is 12. Then we've got to do our subtractions in order from left to right. So we've got 16 take away 12, that's going to give you 4. Take away another 1, and that gives you your 3 that you can see here in the table. So like I said on the first question, break it down into these 3 steps, and that will perhaps eliminate them or reduce the risk of making any small errors. If we'll have a look at 1 then, so 1 squared is 1, 3 times 1 is 3, and then we've got to do 1, take away 3, take away 1, so 1 take away 3 is minus 2, take away that other 1, and you get minus 3 just here. If we have a look at some of the negative numbers then, so minus 1 squared is 1. 3 times minus 1 is minus 3. Remember that whenever you do a positive times a negative, you will get a negative answer. So then we've got to do 1 minus minus 3. Now remember that when you subtract a negative number, it becomes an add. So that should be 4 just there. And then we've got 4 take away 1 to give you the 3 that you can see in the table. I'll do the minus 2 as well. Minus 2 squared is 4. Then we've got to do 3 times minus 2, which is minus 6. Then we're doing 4 minus minus 6, which is going to give you 10, because remember that becomes an add. And then 10 take away 1, give you the 9 that you can see in the table.
So as you can see, I've already got all the plots and the points plotted on this one. So we've got 4, 3 just there. So if you want to see some examples, 2, minus 3 down here, minus 1, 3 just there. Then we've got to do the same again. We've got to draw a nice smooth curve like this. Oh, there we go. Right, and the bottom of this particular question asks you to use the graph to find an estimate of the turning point of the graph. So if we take a little look down here, well, it's going to be about, if we look at our coordinates, it's going to be probably about 1.5 for x. So we can write 1.5 just there. And then it's around about minus 3 just there for that one. So turning point, remember, just is referring to where the graph starts to curve around.
Okay, so here is your final example. So pause your video and have a go. And here is your answers to these ones. So if we just take a couple of numbers out as examples, so let's do that 4 perhaps. So here we've got 7 times 4, which is 28, and then we've got 4 squared for the second part here, which is 16. 28 take away 16 will give you the 12 that you've got just there. Let's look at the 2 then. So 7 times 2 is 14. 2 squared is 4. Not 14, 4. And then 14 take away 4 gives you the 10 just there. Now take care on your negative numbers on questions like this. So 7 times minus 1 is minus 7. Minus 1 squared is 1. And then you're doing minus 7. Take away 1, so you are moving further away from 0 there. That's going to give you minus 8, as you can see in the table.
So I've plotted all your points on your graph. Now you've got to be really careful on graphs like this because you've got 10 squares here between 0 and 5. So those 10 squares are worth 5. So if you do 5 divided by 10, that gives you 0.5. So every small square is worth 0.5. So on some of the trickiest scales, it's always worth trying to figure out what one small square is. Okay, so to do that, take the amount for those 10 squares and then divide it by 10. So you can see why this point here is 4 squares up from the number 10, because you go in 10, 10.5, 11, 11.5, and then up to 12. Now you'll notice here that the shape of the graph is slightly different, and that's because we've got minus x squared here. So when you've got minus x squared, it's going to form a sort of N shape. So we just draw it the same way though. 3 hands through your points, and there we go.